Joining us here today shows the interest you have in caring for our reefs. We thank you because we are currently standing at a crossroads where the actions we take today will help to determine the future of our coral reefs. Today I will be telling you about the Hawaiian Ko'a card for evaluating coral health. I'm sure many of you are familiar, but for those who aren't, in Hawaiian, Ko'a means coral. I will be telling you how this tool can be used to evaluate coral reef health statewide. We are pleased to announce a new tool that we have developed over the past 2 years that will be used by managers, researchers, educators, students, and citizen scientists to assist the state of Hawaii in understanding the impacts of climate change, organizing response teams to assess these impacts, identify areas of resilience, and provide managers with data from every island to develop conservation and restoration strategies. We will be sharing with you some background about coral reefs, how climate change impacts our reefs, the status of Hawaiian reefs, the phases of development for this Hawaiian Ko'a or coral card, and what this means for the state. Coral reefs are important. They provide countless direct and indirect contributions to overall ocean health and human well-being. Healthy coral reefs can serve as protection from coastal erosion through their complex structure that dissipates the force of incoming currents, waves, and storms. Many in our community depend on subsistence fishing, demonstrating unique cultural significance. The fish that grow and live on coral reefs are a significant food source for over 1 billion people worldwide. Coral reef organisms have also been important sources of new medicine being developed to treat cancer, arthritis, asthma, ulcers, bacterial infections, heart disease, and many more. Searching for potential new pharmaceuticals in marine environments is a relatively new practice, with much more to be discovered. Lastly, our recreational activities are dependent on the reef. From snorkeling to diving to the reef that creates your favorite surf break, we depend on them for our emotional well-being. And many of us also depend on them for our jobs and the economy. Hawaii's economy is strongly dependent on tourism, with over 7.5 million visitors annually. 85% of these visitors participate in ocean-related activities during their stay. Cultural ocean practices will be heavily impacted by climate change. When corals are stressed, they are more susceptible to disease. Fishing and shoreline gathering will be greatly reduced. Ocean recreation activities may shift, and these changes in reefs will lead to reduced tourist appeal. We are facing massive declines within the next couple of decades. These threats have been identified on both a local and a global scale. Local impacts include overuse, pollution, sedimentation, introduced species, and heavy fishing pressure. These local disturbances are added to the global impacts of rising sea level, rising ocean temperatures, and changes in ocean chemistry, and are threatening the stability of our reefs worldwide. Since the Industrial Revolution, ocean temperatures have steadily increased, reaching levels that have caused massive mortality throughout the world in the last 2 decades. In the 1970s, prior to a global bleaching event, Dr. Paul Jokiel, the founder of the Coral Reef Ecology Lab, was the first to observe bleaching through a heated effluent of a power plant on Oahu. He noticed that the corals surrounding the outfall were pale in color. In manipulative laboratory experiments, Dr. Jokiel found that corals bleach within 1 to 2 degrees Celsius above their summertime maximum temperature, depending on the species. This still holds true today, and these values were used for part of the baseline when NOAA's Coral Reef Watch was developed. The main threat to Hawaii is bleaching from elevated temperatures. Coral bleaching, or the loss of symbiotic algae, is symptomatic of stress in reef-building corals. Several scenarios can cause corals to expel their symbionts, thus exposing their pale white skeleton in a process referred to as bleaching. Corals can bleach due to freshwater input from large storm events, high sedimentation, increased light irradiance, increased temperature, or a combination of all of these factors. Hawaii was an exception to widespread bleaching events until 1996, when the first bleaching event affected Hawaiian reefs. The second bleaching event in Hawaii occurred in 2002. Both bleaching events were relatively short in duration, and thus coral recovery was high. Conversely, Hawaiian reefs experienced unsurpassed bleaching on a statewide scale during the multi-year bleaching events in 2014 and 2015. In 2014 and 2015, nearly half of the corals in the state bleached, with 35% suffering mortality. NOAA's Coral Reef Watch is a good resource that is easily accessible. Their real-time data will show you the areas at most risk of bleaching and make predictions worldwide. You can also sign up for bleaching alerts for your specific region. In Hawaii and worldwide, bleaching events are increasing in frequency and severity. Recent predictions in Hawaii expect severe bleaching events every 6 years. Traditional coral health surveys during times of stress use a 4-point scale: live, pale, bleached, and dead. These surveys were designed to be the most cost and time effective, being able to survey a larger area in a shorter amount of time with standardization to bleaching status. However, these categories of bleaching status do not tell us how the coral is performing physiologically while it's bleaching. The need for an easy, quick tool for performing bleaching surveys as they relate to the physiological parameters of the coral is what drove the Coral Reef Ecology Lab to develop the Ko'a card for Hawaiian corals. Over the past 2 years, the Coral Reef Ecology Lab has performed 2 sets of experiments, card validations, and testing, which has led to the 4th edition of the card that we have been passing out this summer. The first lab experiment used over 600 fragments from 6 species of Hawaiian corals. We exposed the coral fragments to a simulated natural bleaching event by slowly increasing water temperature. As the corals lost their color, they were photographed by professional underwater photographers Yuko and Keoki Stender to assure natural colors and uniform consistency. We then subsampled daily for measurements of symbiont density, chlorophyll A concentration, photosynthetic state, fluorescence, and electron transport rates. From this first experiment, we ended up with over 10,000 colors, and the most common colors were selected for version 1 of the Koa card. These color factors were then correlated with the health factors at various stages of bleaching. Once we had conducted the first lab experiment, we performed a second simulated bleaching event with around 100 fragments of coral to validate the results of the first experiment and to revise the Koa card. We also validated the card in the field to determine each color's abundance and distribution in shallow water. We found that although we used 6 species of corals within our bleaching events, the card worked on 17 species of coral found around Oahu. We then wanted to look at how the card differed among observers. We asked tour and school groups visiting the Hawaii Institute of Marine Biology to use the card on several coral fragments and determine their color. We found no significant correlation between observer precision and observer age, gender, coral familiarity, highest level of education, or ease of use. Between versions of the Ko'a card, a new biodegradable material was tested to see if it would compromise the Ko'a card by fading or scratching. For sun trials, the card was placed on the roof in direct sunlight and weather elements. In saltwater trials, the card was submerged in an open-flow saltwater tank, and for abrasion trials, the card was scraped against the sand and dead coral rubble. The only environmental factor that showed a visible difference was abrasion, yet the only thing that would scratch the Ko'a card was vigorous scraping with dead coral rubble. Although the new biodegradable Ko'a card appeared resilient in this 18-day trial, please remember to store it out of direct sunlight and rinse with fresh water after every use to prevent fading and other damage. Use of the Hawaiian Ko'a card can be simple and fun. First, you will select a survey technique. Then you will select a coral and record its shape and find the majority color using the wheel while avoiding the tips and margins of the coral. Lastly, you will decide how much bleaching is occurring in the larger area. You will be asked to input whether it's less than 25%, 25 to 50%, 50 to 75%, or between 75 and 100% total bleaching in the reef that you are making observations on. First, you will choose your survey type. There are two survey types we would like you to use, transect or haphazard. For a transect survey, you will roll out a rope or line that is marked every 3 feet. Under this marking, you will survey a coral. If your line is unmarked, simply count 3 cycles of fin kicks along the line and survey the coral closest to the line at that point. For a haphazard survey, you will select corals in no particular order. One example would be to swim along the reef and survey corals after every 5 fin kick cycles, or to survey the exact same notable coral heads every month. Next, you will record coral shape or morphology. This is important to help us determine which types of corals are most affected. The easiest to identify is branching. However, some corals are highly branched while others have short branches. Some species have thin branches while others have thick branches. Mounding corals can form large or small mounds, and they can be knobby, lumpy, or smooth. Crust corals grow close to the substrate and can form a crust over whatever shape the substrate or bottom is. Plate corals form thick or thin plates that are easily distinguished from other shapes and types of coral. If you're having difficulty remembering the coral shape in the field, remember that you can turn your Ko'a card over and it will give you a reminder of these 4 coral shapes. This photograph has 2 coral shapes represented. In the center we can see a crust coral, while on the edges we can see a branching coral. In this example, we have 2 different species that are the same morphology. Both of these corals are encrusting corals or crust corals, and the one on the left is a common rice coral, while the one on the right is a ringed rice coral. This example contains 3 coral shapes. In the upper left, we see a mound coral. In the center, we have a crust coral. And in the lower right, we see a branch-shaped coral. Next, we will ask you to record coral color. You will use the front side of your Ko'a card next to the coral you are surveying. Rotate your Ko'a card until you find the closest match for the majority coral color of that coral, while avoiding the tips and margins, because at these areas the coral is growing and is likely to be lighter in color. Lastly, decide how much bleaching is occurring in the larger area or the bleaching extent. You will be asked to input whether it is less than 25%, 25 to 50%, 50 to 75%, or between 75 and 100%. For example, looking at the reef below, I would record 25 to 50% bleached coral and 25 to 50% dead coral with very few healthy-looking corals. Remember that the more observations you make and record, the more helpful your data will be. In Hawaii, we are expecting a severe bleaching event to occur every 6 years. PACIOS is currently in the process of creating real-time data maps of coral bleaching surveys performed with the Ko'a card, including a phone app and image upload capabilities. For now, all data can be uploaded to the Coral Reef Ecology Lab website. Please remember to also report your name, reef location, date and time, and depth. And if you are using the Koa card with scuba, please remember to bring a flashlight to capture the true colors of the corals and the card. While we have donated our time and effort to development of the Ko'a card, we have had financial support for travel and supplies from the Castle Foundation and the Hawaii Community Foundation, and printing donations from a Colorado-based company, Condit. We are very grateful for the generous support from our sponsors and the community. Please let us know if you have any questions. Thank you for your time.